Hi, in this video we're going to look at some of the different types of graphs that routinely come up as part of the problem-solving element of the higher human biology. So line graphs, really common, and they may be a single line. So example here, you've got over a period of time, something that is changing. So you could be asked to read data from the graph, state trends and patterns that you see from the graph, or do calculations based on the values in the data points from this graph. So single line, easy enough to follow. You've got your individual data points. So for example, in the year 1970, there were 300 cod stock biomass, so 300 tonnes. Let's up the factor by putting in double line graphs. So these are the ones always worth taking time to read over and familiarise yourself with the key. So here we've got, again, over a period of time, this time a culture period in days, we're comparing the human stem cell number with this solid line with the glutamase activity in units with the non-filled in data points. Okay. So the graph below shows the changes in number of human cells in a culture and the activity of the enzyme glutamase present in cells over an 8-day period is also shown. So similar kind of skills, pulling out data from this graph, doing calculations with that data, stating your trends and patterns. So for example, on day 6, there were 8 human stem cell numbers. Okay, so know which side you need to read the values from. Another thing that could be asked from these double lines is, for example, what is the human stem cell number when the glutamase activity is 4, for example. So what you'd have to do is find the glutamase activity at 4 and go up to where that corresponds with human stem cells. So if you're ever having to compare these two together, remember, always go up or down, never side to side. Could also potentially have a bar graph. So pretty standard example here. So showing, instead of things changing over a set period of time, we've got distinct categories. So here we've got the time, the different days, so 5 different days, and the distance travelled in kilometres by these birds. So the greatest distance travelled by the pipit is on days, and that's, again, looking at the data, get you to pull out some of the data points. So we know we've got the highest distance travelled on day 3. From day 2 to 3 it increase, from 3 to 4 it then drops. 1 to 2 it also increase from 20 up to 60. So we're looking for this greatest data points. Okay. Another type of bar graph that comes up is the stacked bar graphs. So we only then look at the part that is relevant to the question. So for example, the economic yield in the red 5 plot would be 500 grams of dry mass per metre squared. Whereas if we wanted the remaining biomass, we just look at the white box, so from the 500 to the 2500, so a total of 2000 remaining. Another type of graph that comes up are your scatter graphs. So we're looking at how something changes over time, when we're really more interested in the average and where all the individual data points sit. So this line here is our average line. Any dot above that is above average, any dot below is below average, but we can still look at the individual dots to get their individual values. So this dot here is representing $400. So I hope that's helped give you a quick run through of the different types of graphs that you can expect. Other problem solving skills that routinely come up, so make sure you can do a percentage change, you can do ratios, work with tables, calculate percentages and averages or means. So do check out the problem solving video for those. And specifically for the physiology and health unit, make sure you can do the pedigree charts, make sure you can do calculations such as cardiac output and BMI, as these will all contribute to the problem solving marks from the assessment. Any other questions, please let me know.